So in this video, we're going to talk about different types of graphs. And before giving you a different type of graphs, I want to give an example related to a computer network. Suppose you have this computer network. Obviously, this computer network can be modeled using the graph in which the vertices of the graph represent the data centers and the edges represent communication links. And similar to the last video that we have on introductions to graph theory, we visualize graphs by using points to represent vertices and in this case line segments to represent edges. And this particular figure is an example of something called a symbol graph. So this is an example of symbol graph. Now, how could you identify a symbol graph? So a symbol graph is that each edge connects two different vertices. So each edge connects two different vertices. And the vertices are used to identify the data location. In this case, you have San Francisco, Los Angeles, Denver, Chicago, Detroit, Washington, and New York. The next property for you to identify a symbol graph is that no two edges connect to the same pair of vertices. That means that if you have another edge like this is not allowed to be called a symbol graph. If you have something like this, there's another name for this type of graph. For now, this is just going to be a symbol graph. The third property for a symbol graph is that there should be no loops. That means no edge starts and ends at the same vertex. That means for a symbol graph, this is not allowed. So you have data center at Denver and you have a loop at Denver as well. So this is not allowed in the symbol graph. Now the last condition is that this should be undirected. So that means there's no directions for edges. So these four conditions allow you to identify a graph you're working with is a symbol graph or not. All right. And in this case, we are working with undirected graph. That means we don't care about the direction from one location to another locations. For instance, we know that there's a commuter rail going from South Stations to Bridgewater. We don't care about the directions. We just care about if there is a path between South Stations and Bridgewater. So there's no directions whatsoever for a symbol graph. Now we're going to move on to other type of graphs. So similar to the last graph, but you add more edges into the data centers. That means you have more communication links or you have more edges in the graph. If you see something like this, since you have multiple edges connected to the same vertices, this is called multigraphs. So this is an example of a multigraph. And again, you identify a multigraph by looking at the number of edges between vertices. So there are multiple edges connecting the same vertices. So multiple edges connect the same vertices. You can also have loops in a graph. This is an example of a graph where loops are presented. So for loops, that means that edges connect a vertex to itself. And it makes sense for the type of data center that we are working with, because sometimes a communication link connects a data center with itself, perhaps a feedback loop for diagnostic purposes. And When you look at this graph, not only you see loops, but also a line segment connecting vertices and curved edges connected vertices. If you see something like this, it's called the pseudographs. So this is an example of a pseudograph. And how can you identify a pseudograph? You have loops and multiple edges. Connecting the same pair of vertices or vertex to itself. The same pair of vertices or a vertex to itself. So all the examples that we have so far are undirected graphs. And of course, there should be some directed graph as well, and when you have that, it's called digraphs. So you have directed graphs, or digraph for short. So the definitions is very similar to the definitions of a graph. Right? So a directed graph, of course, still consists of G equal to V, comma E, and this consists of a non-empty set of vertices V and a set of directed edges. Now, for instance, you go back to the symbol graphs. This is undirected graph. Now, if you give some directions here by using arrows, you can indicate that this is an example of directed symbol graph. So for a direct symbol graph, all the properties of symbol graph should follow, except for the last conditions, that is, the graph is directed. So the first condition is that each edge connects two different vertices, no two edges connect the same pair of vertices, and there should be no loops in the symbol graphs. Right? And in this case, it's directed symbol graph. In all the examples, so if you give some directions here, this example is an example of directed multigraphs. And in the last image, you can add in some directions as well. So at this point, it does not really matter what directions that you're going to get. Just that I want to illustrate the concept that this is directed graphs. So in this case, you not only have curved edges, straight edges, but also loops. And for the case of directed graph, this is also called the directed multigraphs. Which is slightly different from the case of undirected. For undirected graphs, you have multigraph and you have pseudograph, but for the directed graph, you have only directed multigraph. And there's another type of graph, it's called the mixed graph, where a graph with both directed and undirected edge presented in the graph. So a graph with both directed and undirected edges is defined to be a mixed graph. Now I'm going to summarize the information a little bit in a table. So far we have a different type of graphs, and it depends on the properties of edges, loops, or multiple edges, we can have a different type of graphs. So in this table, you have the type here, the properties of edges, and we want to know if multiple edges are allowed and if there is any loops at all. So the first type of graph is called the symbol graph. And for the symbol graph, this is undirected. And no multiple edges are allowed, and there should be no loops. Now for multigraph, this is also undirected. They allow multi-edges and there should be no loops. And for pseudographs, this is undirected. Multiple edges are allowed and loops are also allowed. For a symbol directed graph, so symbol digraph, this is directed. Multiple edges is not allowed and there should be no loops. Now for directed multigraph, so the edges are directed. They can have multiple edges and they also allow to have loops in the graphs. And the last type is mixed graphs. They can be both directed and undirected, depends on the edge of considerations. They allow multiple edges and they allow loops in the graphs. For this type of graphs, you can identify the order of the graph based on the number of vertices and the size of the graph based on the number of edges. Very similar to the example that we showed in the last video. So that's it for me in terms of introductions to graphs. In the next lecture, we're going to talk about paths and circuits.